Hello, good afternoon. My name is Matt Thomas, and I am here from Verisign to present with my coworker, Bill Carroll, who's joining us remotely, about exploring the transitive trust of delegated TLDs. For those of you that have been following the DNS-OARC thread, there was a recent one about trafficmanager.net, which has a lot of similarities you might pick out in this. So what do we hit here? All right, so I'm sure most of you are familiar with the concept of transitive trust. It's not exactly new. It came out in 2005 by Ramo Bersarian and was further developed by Eric Osterweil and Danny McPherson at Verisign around 2010. Verisign also developed a transitive trust tool, which you see the link up there. You're welcome to go to that. This tool works by taking a single domain name and expanding the name delegation points and understanding the transitive trust base of that. And when I say that, I am talking about the space for a domain name. You're talking about computing the trusted computing base, which obviously then talks about the redundancy and resiliency of that particular namespace. And on the counter side of that, you're then talking about what particular vulnerabilities that namespace then incurs, specifically the attack surface. And as we saw on the DNS-OP thread around trafficmanager.net, this also then incurs potential operation costs, complexity, and ultimately performance. So if we take a look at a simple transitive trust example out of the tool, here we can see Verisign Labs transitive trust graph. It's going from the root to rootservers.net over to GTLD servers, ultimately going to NSTLD, and then VeriSignLabs.com. You can have simpler transitive trust graphs. Here's one for a simple in-domain TLD. It has, the standard again from the root to rootservers.net, as well as the TLD and all the in-domain name servers within that. And then on the flip side, you can have very complex transitive trust. Here's an example of a crunchy code TLD, which you can clearly see how this gets very messy very quickly. I think this has 35 different objects in it and 13 different TLDs that it references itself. And so one thing you'll see in this is that essentially all of these TLDs that we're going to inspect today rely on rootservers.net, which ultimately relies upon .net. Now, for the remainder of this presentation, I am going to remove this dependency since it's inherent on all TLDs. It just simplifies the analysis going forward. Which gets us to what is this presentation really focused on? And here we're talking about changing the tool from going from a single domain name to something that can take a set of domains or namespaces and create a larger connected graph. And in this research, what we did is we built this tool, and now we're going to take a look at all of the delegated TLDs in the root zone. And basically what we're doing is we're running this transitive trust over every single TLD in the root zone, which is going to give us a directed graph. We're then going to merge all of those directed graphs into a single directed graph, apply a taxonomy of labels over top of that, identifying things like country code TLDs, the original TLDs, new GTLDs, the root, so forth and so on. And then we'll also size the nodes based off of graph properties such as the degree going in and out. And what you end up with is this starry night looking picture on the right, but it really is kind of a mess. And so what we're hoping to do is then apply some forced animation to make this run. And great, it actually worked. I don't always test my PowerPoint presentation, but I do it in prod, I guess. And here we can see the directed graph starting to expand, and you start to see some structure of the root zone. And I like to think of this as a bicycle wheel, and you have those spokes coming out around the most of it. And there's, that's covering 3/4 of that area. And then you have this other area at the top that has a little bit more entropy and mixture in it. So what did we see out of that then? We have some preliminary findings that we would like to share. Now, I'll say they're just preliminary because at the end, I'll talk about some additional research we're going to do in the future to enhance this. But finding number one is that there is a significant amount of TLDs out there that are fully in bailiwick, which I guess is the improper term and should be used as in domain now. So we have roughly 938 or 65% of the 1,440 TLDs that we scanned have no dependencies outside of themselves, excluding rootservers.net, which we mentioned we took it away. But if you relax that a little bit and you add additional net SLDs or additional one ComNet SLD, you get up towards of a little over 1,000 TLDs matching that property. So a significant portion of the root zone is structured like this. The second thing we see, especially when we were looking in that little higher entropy area of the visualization, is that you can see consolidation by certain registry operators in there. You have large sets of SLD dependencies that are actual registry operators. You have things like GMO registry in there, Charleston registry, Affilius, so forth and so on. And while I will say from the time that we originally did this analysis to this presentation that those results have actually changed due to mergers. So it's kind of a highly dynamic environment still even today in there. Now, our third section is actually trying to look a little bit more in that red circle area of the directed graph and understanding what's going on there. And what we find inside of that is this is where all the country code TLDs and some of the legacy TLDs or the original TLDs are located. And on the left, you're going to see a table that enumerates a cumulative distribution function for the number of TLDs included in each one of those types of TLDs. So the left columns for the CCTLDs, you can see it kind of goes out to a long tail, right? It starts with 3 TLDs at 42% of CCTLDs have 3 TLDs in them, but it can go all the way out to 13. Versus when you look at the legacy and the new GTLDs, those are more, only have 3 or 4 TLD dependencies in them. So it's a very different structure how those are set up. Maybe this is a byproduct of CCTLDs being set up in a different time or a different era, and that's how things were done. But this is what we're seeing right now. And now finding number 4, we also see that ComNet are the most relied upon TLDs looking at additional SLD dependencies. And on the left side, you can see the SLD dependency TLDs and their counts. And you can go down here, and one of the things that pops out here is you'll also notice that none of the new GTLDs make this list. So it doesn't appear that those types of TLDs have been being used for zone references from other TLDs. So that was some of our preliminary findings. What we're trying to do is understand, looking back at the original work of, again, solving a complexity of this transitive trust property versus resiliency. And there's no sweet spot, but we're trying to understand that by looking a little bit more. And specifically, we also want to look at this longitudinally because we all know here the root zone is not a static place. This is a figure generated by Verisign's Dwayne Wessels, hosted on DNS-OARC actually, that looks at the different types of records inside the root zone over time. And you can see we have major deployments of things like the new GTLD deployment, which I guess we're going to have the new GTLDs soon. You have IPv6, DS, record growth, and then you also have the registry operator consolidation, like I mentioned before. And so what we'd like to do is continue with this work and automatically do this scan daily and create these directed graphs, which we have completed. But this is only one flip side of the coin, or one side of the coin, and we'd like to flip the other side over and actually look at the underlying substrate and look at the IP infrastructure and the network infrastructure, such as ASN diversity or the BGP. Possibly look at other features like, is it DNS-SEC signed? What kind of resolver software is in there? And combine all of these different attributes and measurements into some kind of risk scoring framework that would allow us to do some kind of monitoring and alerting. And then ultimately, we're trying to take this information and then do targeted community outreach and education like we're doing for here today. And with that, I'm happy to take any questions.
Hi, Peter Diesek. What do you mean by trust?
So transitive trust it's inherent. Like if I trust you and you trust Jim over there, and I give you my car keys and you give him your car keys, I don't necessarily trust him with those car keys. But these dependencies during the iterative resolution period, you're expanding the name zones off of that. So implicitly or explicitly, you might have other TLD dependencies or namespace dependencies for the resolution of your name.
So that's for availability and those other TLDs and their name servers and blah, blah. They're all middlemen for me receiving the information, but I don't necessarily, I think, need to trust them because I might be able to cryptographically verify a name server host name's address, for example.
Correct.
So is it really always about trust, or is it just an availability dependency?
I think it's a balance of both, right? It depends on how you look at that.
Petr Pacek, I see. Thank you. Interesting. I want to circle back to the root service net, which you skipped over, which makes sense for the purpose of the presentation. But recently there were proposals to do NS name revalidation in the resolvers. So that would mean that all the resolvers, if they implemented a spec, they would actually go and try to resolve every single letter themselves. And while doing so, it turns out that in our experience, we would exceed the quota we have for the packets going out for a single query, because there's so many hops to jump through that we would just explode the quota or fail the resolution. So the question would be, is there any reason why the root service net has to be inside the net, or is there a technical problem with moving root server names to something inside the root zone itself without the intermediate delegation, or is it just like more political question than technical?
That's a really good question. I don't have an answer for you on that, unfortunately, but a very good question.
Sorry, Ray Bellis, ISC. Petr, there are already proposals that look at the renaming of the root servers so they're not inside a TLD. So you could hypothetically, for example, have a.root, but it wouldn't actually be behind a delegation.
Jacob Zach from Sierra. So we, .catld, we operate Anycast for about 560 top-level domains. And I noticed we were on that list up there. I think you mentioned 26 delegations of various TLDs referencing us in their DNS-OARC set. And ultimately, that is a choice we give customers. We'll give you whatever reverse DNS you want. We would default to something under their TLD, letter.dns.myTLD. There's that old school thought that, well, by using a lot of TLDs inside our DNS-OARC set, that we are making it more resilient in some way, shape, or form. I could see why there'd be a clear difference in the new GTLD world. They're generally, A, B, C, and D, or NS1 through 4, or whatever, under that TLD. Whereas, again, that old, and I don't know if it was a CCTLD mindset or just a legacy mindset within this community, but there was that thought that having multiple TLDs referenced was a good thing.
Exactly. Yep. Thank you.
Petr Pacek, I see again. I want to react to the old school lore that having multiple TLDs is improving things. It turns out that after like in the last 2 years, let's say, DNS resolvers had to implement protections against various denial of service attacks, which forced us to tighten down the limits on number of queries going out and all other sorts of limits, many limits. And it turns out that in practice today, if you have too many TLDs listed in your NS set, it will actually break the resolution, because even though the domain is not intentionally malicious, it will hit those limits and the query will serve fail or not, depending on state of the cache of the resolver, which is like complete nightmare to debug. So what this thing, which was the old lore, you should have multiple TLDs, is actually harmful today. So don't do that, please.
Klaus from nick.at. Regarding the comment from Jack, why some CCTLDs use other TLDs for the name servers, I think that's not on purpose. I think that was just because in the 20 years ago, CCTLDs started to share name servers. So, and that's why, for example, .at made a cooperation maybe with DNIC, with .de, and they shared their name servers. So they shared their IP addresses and they just took over the same name server name. So I don't think there was a technical reason for it, just a practical reason for it. And maybe things should change now to use in bailiwick and to avoid dependencies.
Thanks.
Thanks a lot, Matt.